Hello, this is Mr. Stansbury. I'm going to take you through the 19 C notes on the idea of a limit. At the end of this, you should be able to say I understand the idea of a limit, and also I can find the limit of various functions. All right, so let's start off with an example. So sometimes you can't work something out directly, but you can see what happens as you get closer and closer. For example, x squared minus 1 over x minus 1. Now, we know that we can't put 1 in for x, because if we do, we end up having 0 in the denominator and we can't divide by 0. So anyway, we want to know what would happen if we got really close to 1 but didn't actually hit 1. Okay, so what we do here is we can just start plugging in some values. Okay, so I took the liberty of plugging in some values ahead so we don't have to go through and calculate them all out ourselves. But anyway, so you plug in 0.5 and you get 1.5. Plug in 0.9, getting closer to 1, 1.9. And as you can see, as we get closer and closer to 1 on we call it the negative side of 1, because here's 1 on a number line, right? And then over here towards the negative numbers we get 0.9 and then 0.99 and so forth. So this would be the negative side of 1. And then the positive side of 1 is 1.0, well, I'll say 1.1, 1.01 as we get closer and closer. So this is as you are coming from the positive numbers heading down towards 1. Okay? So anyway, as we are heading to getting closer and closer to 1 from the negative side, this number here looks like it's getting close to 2. It's getting closer and closer to 2 as we get closer and closer to 1 from the negative side. Now when we come from the positive side, again we plug in the numbers, 2.5, 2.1. We're getting also, on this side, we are also getting close to 2 as we approach 1 from the positive side. Okay, so since from both the positive and the negative side, they both approach the same number, then we say that this here actually has a limit of 2. Okay, and we would write that as the limit as x approaches 1. That's what this stands for. X approaches 1 of this function, that's the exact same function as this up here, equals 2. Because as we get closer and closer to 1 from both sides, this number, the value that it approaches is 2. Okay, so that's the idea of a limit. We're getting really close to a number that we know we can't actually plug in, but as we get closer and closer to that, we are getting to 2. All right, let's take a look at another example. All right, and that is, what if we have 3 over x minus 1? Okay, so again, I went through and I plugged in some values. As we're approaching 1 from the negative side, we end up getting -6, -30, -300, -3000. So this thing is getting bigger and bigger. Well, it's getting to be a bigger and bigger negative number. So we say that this is approaching negative infinity. Okay. As we approach 1 from the positive side, we get 6, 30, 300, 3000. So this on the other side is approaching positive infinity. Okay. So these here, the limits, as we're trying out numbers that are getting closer and closer to 1 from both the positive and the negative side, they're approaching different numbers. So since they're approaching different numbers, we say that this does not have a limit. Okay, so we would write the limit as x approaches 1 of the function 3 over x minus 1 does not exist, because again, it does not approach the same number. Okay, just to kind of give you an idea, let's look at this on a graphing calculator to give you maybe a little bit better perspective on this. Okay, so here's our function in the graphing calculator. Okay, so we got 3 divided by x minus 1, and then we go to graph it, and here is the graph. So as it's approaching 1 from the negative side, it goes to negative infinity, just like what we found here. As it's approaching from the negative side, it goes to negative infinity. As it's approaching 1 from the positive side, it's going towards positive infinity. So you can see as x approaches 1 right here, that's this line, x equals 1, then we know that it goes to positive infinity from the positive side, negative infinity from the negative side. So this does not have a limit. It is not going towards the same number. Okay? Okay, let's take a look at some of these on our own. All right, so find the limit if it exists. So what you want to do on this here is you don't want to enter in a whole bunch of different numbers on both sides. What you want to do is you just want to enter in a number that's really close on both sides, the positive and the negative side of each of these numbers here. Okay, so let's just put some numbers in here. Let's try, say, let's see, for -2. So let's try -1.999 and -2.001 and see what we get for both of those. Okay, so let's put this in. So let's do, let's just put this whole thing in together. Now with with a regular calculator, you're just going to want to put the values straight in and calculate and see what you get. But if you have a graphing calculator handy, it might be a little bit easier to try this. I'm just going to enter the function in just like it looks, parentheses. Well, of course, I got to use parentheses on the top here. So we do x squared and then -4, close the parentheses, divide by more parentheses, and we do x plus 2. Okay. Now you can graph this thing if you want, or you don't even have to actually graph it. Let's see, we get this line here. But really what I wanted to do more so is I want to just be able to plug in values. So if you remember, we just do second calculate, and then we're going to do value. And so we want to know when x equals -1.999. And when x equals -1.999, y is -4. Okay, so as we're approaching -2, -1.99, that's actually from the positive side. We go to -4. And then let's do second calculate, value again. And then now let's enter -2.001 and see what we get there. And this one also gets us really close to -4. So then we can say the limit as x approaches -2 of this here equals -4. Okay. Another way that you can actually do this exact same problem is to, you can actually factor this here. Okay, the way we're doing it is just fine. I just want to show you a little bit different way to try this out. Another way to do this is if you take x squared minus 4 over x plus 2, you can turn x squared minus 4 into x plus 2 and x minus 2. And you take that over x plus 2, and you'll notice that these x plus 2's cancel out, reduce with each other. And then if you plug this -2 value in for this x here, you get -2 plus -2, which gives us -4, which is our limit right there. Okay, so that's another way you can do it. You don't have to do it that way, but when they factor like this, that's usually a quicker way to do it. Okay, so you can actually, on this one over here, you can factor it, or you can plug it into the calculator. For this one here, I just want to show you how I think it's actually a little bit easier if you can factor these out. Okay, so, and chances are, if you get something that looks like this, chances are this x minus 4 down here is probably going to be one of the factors up here. So if this was x minus 4, let's see, -4 times what gives us -8? That would be plus 2, right? So we'd have x minus 4 and x plus 2. If you double check that, you would actually, if you FOIL this out, you'd get x squared minus 2x minus 8. Okay, these would cancel, reduce out with each other. And then we put 4 in here, so you'd go 4 plus 2 equals, well, I guess we wouldn't circle the whole thing. We would just get 4 plus 2 equals 6. So the limit on this one should just equal 6. Okay, and then again on the graphing calculator, you could enter it into the y equals and find the values. Or again, if you don't have a graphing calculator, just plain old scientific calculator, choose a number that's really close to 4. So let's do, say, 3.99, and we're going to square it. minus 2 times 3.99 minus 8 gives us a pretty small number here, and we're going to divide that by 3.99. Oh, let's see, we're going to have to put parentheses in here. We got 3.99 excuse me, minus 4. Close our parentheses, hit equals, and we get 6 here. Okay, and then you'll also find if you plug in 4.01, you're going to also end up really close to 6 on this side as well. Okay, we're almost at 11 minutes here, so I'm going to stop it here, and then we're going to pick back up and do C, D, and E, and then one last example on the next video. All right.